Sempf, and he's talking about weaving security into the SDLC. Welcome, Bill Sempf.
So what happens when you change software late in the game? Yeah. Anybody know what kind of bug that is? That's exactly, who said that? Oh, I wish I had swag. Yes, that's exactly what that is, the box elder bug. We had a sudden influx of them, and my son needed to keep an insect farm for a week for his Weeblos badge. And so I ended up, while I was writing this talk, I ended up looking up this bug and found this fantastic picture. That's good. But you're right. Change software late. Late changes of software, cost increase. You make bugs because you're changing pre-existing lines of logic that are already honed to a certain degree. You create bugs, you create cost. Really, we introduce the majority of bugs in software in development, right? And then we find most of them in test. That's the way it's supposed to work, and it works out pretty well. Those that we have to fix in production cost 23 times as much as the bugs that we fix in QA. Right? So if we, 23 times as much as we'd find them in requirements gathering, if we predetermined that the bug was going to exist. So the question is that we have to answer here today: what kind of bugs are found in production that should have been found in requirements gathering that we see every day? And of course the answer is security flaws. They are just another defect. To the developer, a security bug, a security flaw, is just another defect in the code. And it needs to be treated as just another defect in the code from the perspective of the development staff. The way we are treating it today, where we don't even test for them until right before production, is causing that cost escalation, right? If there is a logical flaw, okay, a direct object reference flaw, you've got, I just tested an API the other day where we had, what the heck, oh, it's the quotes thing. So the REST API, quotes were referenceable by an integer. So I just went to burp, and the integers weren't sequential, right? But it still was just a 6-digit, 7-digit number. So I just went into burp and said, okay, well, try everything from 10,000 to 1,000,000. And then went and I got a beer. And when I came back, I had a list of 90 quotes. Oh, that's pretty cool. So I ran the API call for the quotes list for my account, and I had 40. So there was a logic flaw. Somebody didn't think to check to make sure, hey, if someone's looking at this quote, make sure they're actually allowed to look at that quote. That's a requirement, right? That flaw could have been found in a requirement, but now it's been found in production. So it's going to cost 23 times as much to fix, 23 times much money to fix. As we've discovered with all these. I mean, some of these cost significantly more than 23 times as much to fix, am I right? So these companies didn't really think, didn't consider security flaws in this way, did they? They went and said, we're going to follow the standard path where we're doing QA testing through a Scrum cycle, and then when the product's done, we're going to do our security analysis, and then the results of the security analysis are separate from the QA results because it's different, right? I mean, security and the analysis of the application security is going to be different than all the QA bugs. So they're separate. So this goes in a report over here on somebody's desk, and all these bugs in QA get entered into Jira and get fixed as part of the Scrum cycle. And that's why they end up on this slide. So what we're going to do instead is we're going to fit security checks into the software development lifecycle. Gates at the end of each tier. Okay? If that's confusing, I promise it won't be when we're done. This is the simplest thing ever. But it needs to be laid out, and that's what we're going to do there. But first, let me tell you who I am. My name is Bill Sempf. You can find me on Twitter I hang out there a lot. I like it. It's like IRC, but it's more public. And you can't get kicked as easily. So you can come find me on IRC. I'm a husband and father. Actually, my family was supposed to come with me. My wife was registered at the. When I went and checked in, they're like, "And is Gabrielle Sempf with you?" I was like, "Well, no, no, she isn't." But she wishes she was. Anyway, and I have 2 young kids, a 9-year-old son and a 4-year-old girl. And I'm glad to see Hack for Kids is a sponsor. If you've got kids and you haven't done anything with Hack for Kids, I spoke at Circle City Con last month, I guess it was, and Hack for Kids was there. And my son took a Aircrack NG class with one of the devs. And he had no idea. I mean, I was totally geeking out. He had no idea what was going on, but he had a complete blast. He can't tell you what he did, but he knows what the end result was. He knows there's Wi-Fi I didn't have access to, and then I did have access to it, and I got to click a bunch of cool buttons in the middle. I don't really know what I did, but it was fun. So I strongly recommend it. I'm an author. I've written for Rox and Wiley. Wiley actually bought Rox when they folded back in, I don't know, 2006 or 7, somewhere around that time frame. And Rox is now an imprint of Wiley. Now I write for the Dummies books, the yellow and black ones with a dummy guy on the front. It's kind of appropriate, really. I call myself a software composer, not a normal phrase, but I hate the term architect. I got the term composer from this book called Lorem Ipsum. Lorem Ipsum is a 138-page children's book by Carlos Buena. And it's about software engineering, computer science. It's a 136-page kids book about computer science. I'll tell you, I learned more about computer science in that 136-page kids book than I did in 8 years of college. In the book, Lauren walks through this fantastic land with her mentor and discovers each of these different boroughs, sort of the town, like that are all modeled after software development methodology. So one of the groups is the brute forcers, where they pile rocks upon rocks to build edifices, and then when they collapse into their own weight, they put more rocks on top of it and use that as the foundation, and like that. Then there's the composers. The composers is this beautiful land with these tall spires and these fantastic living places. And the way the composers work is they make beautiful things out of beautiful things. And that's very much how I see myself as a software developer. I haven't twiddled bits since I was 10. We're building things on the shoulders of giants. We're taking pieces of software and combining them in such a way to make beautiful things. That's very much what I do and what I'm into. More recently, though, I'm an application vulnerability, and that doesn't even fit on the slide, does it? I'm a pen tester. I'm not really a pen tester. It's just the term you hear more often. Pen testers and vulnerability analysts are different breeds. A pen tester is given a job, generally. Bill, go get our Etsy password file. Go. And then I can use whatever methodologies I want to get that. I can sweet talk the secretary, I can pick a lock on the front door, I can break into a vulnerable web application, whatever it takes to get it. And then I write a report on the path I took through your company to get that information that I was supposed to get. Vulnerability analysts are different. We take one application and find every flaw. So arguably it's more demanding, right? Because the pen tester only has to find one thing wrong. Well, or a chain of things in order to get what they need to get. Whereas I am supposed to find everything, but in a very narrow scope. Also, I'm much less likely to end up in jail, which pen testers do. So I'll leave that to them. So personally, I'm a home brewer, though I didn't bring anything with me this time. I am a lock picker, and if Adrian really set up the village, then you'll probably find me out there for a little while. I'll bring my gear out and we'll do that. I started the Columbus Lock Sport International group. I'm from Columbus. I didn't say that, did I? I'm from Columbus. I am a ninja, and yes, you can only see me because I'm allowing you to. And I don't mean like a security ninja. I'm actually 5th Cube Banjin-Shukai Ninjutsu, like actually trained in it. I'm not a security ninja. And I'm something of an insurrectionist. I leave this slide in here, even though I'm talking to a security group. To security people, I am not. But to developers, I have a habit of opening my mouth at the wrong time and saying the right thing, if you know what I mean. Especially like when there's C-levels in the room that aren't supposed to know. Yeah, anyway. So, do I have any developers in the room? Well, I know I have one developer in the room. Do I have any other developers in the room? Okay. I know most of you probably write some code at some point, but I mean somebody who gets up in the morning, doesn't get check out, codes all day, doesn't get check in, goes to the bar. No, okay. All right. So let's talk about the software development lifecycle a little bit. So there's a process to building software, okay? And honestly, it doesn't matter whether you're building your church volleyball team website or you're building project management software. That's a bad example. Building invoicing software. You are going to go through a process. At some point, you need to figure out what the software is supposed to do, right? What it's supposed to accomplish as a thing. The volleyball team's website is supposed to get the schedule in the hands of the public, right? You've got to figure out how you're going to go about accomplishing that goal. You know, what are the individual steps? Well, somebody's got to be able to edit the schedule. Somebody's got to be able to see the schedule. You've got to figure out how you're going to tell the computer how to do those steps. Because it's really nice that you wrote down a list of things the software is going to do. You've got to figure out how the computer is going to go about doing that. Okay? Then you actually have to do it. You actually have to build the software. So obviously we've already gotten 3 steps out of the way before we wrote a line of code. And it happens even in agile environments. Well, we'll talk about that in a little bit. Even very much in code first environments, someone at some point, even if you don't make a document, must go through those first 3 steps. Because otherwise, you don't even know what you're doing. You're just putting code on the page. After development, we have to test it. Even if it's just pressing F5 and going, okay, it works, there's still some testing that takes place. Then, we have to make it available for use. While it's available for use, we have to go through a process, hopefully a continuing process, of fixing it when it breaks and changing it when something about our original requirements has changed. And then finally, we have to get rid of it. At some point, it's going to die, even if it's that we forgot about it and the hosting company closed. At some point, it's going to die, and so there will be a sunset process. So what about Agile? So everybody's doing this Agile thing, right? And there's implementations of Agile like Scrum, where you supposedly take a 2-week sprint and then have a rest and a retrospective, and then plan the next one, and then do a 2-week sprint. And during the sprint, you get a certain number of user stories, cards done. And those are just requirements. The same exact process takes place. It's just significantly faster. There is absolutely no difference in what I'm talking about from a monolithic, let's write the whole thing down and then build the whole thing, or doing it in something agilist like Scrum. Zero difference at all. All of these steps still take place, and all of the stuff we're going to talk about going forward still works. Okay? And by the way, I made a comment about what does SDLCs eat? Project managers. That's what they eat. Let's start with scoping. So scoping is where you figure out what problem it is you're trying to solve. And this is a good time to apply a certain number of security principles to your software development. If you think about security when you're thinking about what the software is going to do, then you'll be much more likely to apply the principles when you get further on in the project. So what are these security principles? Well, defense in depth, does it have the text on it? Defense in depth is one of the core application security principles, and it states that every layer of the system deserves its own security modeling. So in the scoping stage, you decide what the expectations are for the security of the system. And you can apply defense in depth to that expectation. A positive security model is one that defines what is allowed in a system, rather than something that defines what isn't allowed in a system. So, for instance, if you have a drop-down list of counties, rather than checking to make sure that an attacker hasn't injected a nasty character like a bracket or a tick mark, you simply say, if this input isn't one of these 33 counties that I already know exists, then reject it outright. So we've listed what we can do. On the principle side of things, if we consider the positive security model up front, that makes us categorize our object model better as we're scoping. We tend to get a much better grasp of what the business entities are and what collections of things are in those business entities. So exception management isn't something we generally think about in scoping, but if we consider how we're going to fail security when our software fails, during the scoping stage, it's significantly more likely when we move into design that exception management is something we'll handle. Exception management is very important because software exceptions are one of the leading causes of information disclosure and application security. If you handle exceptions well, you're much less likely to leak information to an attacker. The principle of least privilege states that a user should begin with no privileges in the system and be given them as they are needed. When we're scoping the system, one of the things we have to determine is who will use the software. If we think about it from the perspective of least privilege, it allows us to approach the concept of user roles from a secure side. And we're not going to do anything with this until we get into requirements design and development. But now we've started to consider it from, rather than, everybody has access to everything, and then, we need an administrator role that gets this, and so we need to block it. No. Let's start from the perspective of least privilege and work our way up from there. So separation of duties is largely a process-driven piece from the perspective of software development. And this is a good time to remind yourself that developers code and testers test and operations deploys and never cross the streams, right? Considering that when you begin the project makes it a lot easier than fixing it later on down the line. Security by obscurity is a weak security control, and it nearly always fails and should be avoided. When you're scoping your project and when you move into design and requirements and design, determine if any of your security model is based on simply someone not knowing something. That's generally a bad idea. If you hide something in a software application, I will find it. So don't do that. Do not trust the client. Input is always a risk. So when you're scoping your application, determining where the data is coming from and how you are going to defend yourself from potentially malicious data will once again carry into the requirements and design phases of the project, and then finally into development. So if you've already considered in scoping where input comes from and how it matters, then by the time you roll into the development phase, the developers will already have a very clear-cut input validation pathway, especially if you combine that with a positive security model. So what we've done now is we've made this layer cake of security in our scoping process. So while we've discussed what the software will do, we have discussed what the software will do securely, which is not generally something that is an upfront consideration of software, but it should be. So that's our first gate. We move into the requirements gathering phase. Requirements gathering phase is where we start to determine the individual goals for the software, right? Some security features get their own requirements because they are very important parts of the software. It's something the user sees. It's an expectation. We can write it down. It would get a function point if you're into function point counting. It would get a card if you're Scrum, right? Some security requirements get ignored because all they do is secure the app. They don't provide any functionality that the application might need. There's no other redeeming features of those, right? So what kind of features get rolled into requirements often? Well, authentication and authorization are obviously key. If you have an application that has any protected access at all, there has to be a login screen. So probably 1A in your requirements is that the user needs to be able to log in, and we need to determine what access they have within the application. So authentication and authorization regularly have a place in the requirements document already. Encryption. This isn't as user visible as some things, but because it has so many implications with interacting with other pieces of software, it will normally also get its own requirements. And it's a good thing too, because encryption is hard. It's very hard for developers. We have a difficult time with it. So building it in the requirements side is a good idea. Stop playing with that. Exception handling. sometimes is a requirements piece and sometimes is a design piece. It depends on how your software architect feels that day. But very often it gets its own requirements. The reason is because, especially in enterprise development, we so regularly have high-level exception handling requirements at the organization level, where we need to, how we need to track what systems we need to report exceptions to, that it ends up being in the requirements document because it's a corporate requirement, not so much that it's a user requirement. Still, it's very commonly very commonly found in a requirements document. And finally, data access, because pretty much all applications today are data-driven. So the access point and how we're going to map it to our application is often a requirement. But what doesn't get written into the requirements document? Well, encoding is the first one. We are so used to our frameworks encoding for us, we have stopped concerning ourselves with input encoding, which is why the rash of cross-site scripting. Data coming in and data coming out and handling encoding properly should be a requirement of any system that's being built. When we went back to scoping and we looked at our positive security model and we looked at how we're mapping our objects to begin with, at that stage of the game, figuring out the requirements for encoding can be placed in the document. Input validation falls right in with that, right? Especially when we're doing things like mashing up data coming in from external services. That's still input to our system. And we cannot trust that input. Even if it's coming from a trusted partner, you don't control that data. Writing requirements for validating that what's coming in from a partner service, extraordinarily important. Session management is often just an assumption. So authentication, authorization, and session management, right? The three parts to the user login experience. The user you assure the user is who they say they are, then you figure out what the user can do in the application, and then finally you maintain some state over time. Those first two, they get requirements. But the actual maintaining of the state is very often left for the developers to figure out on their own. Part of the reason is because the frameworks we're using for authentication very often have their own session management. Nonetheless, there needs to be security requirements built in such a way to make sure that there aren't magic tokens in the session management. Finally, cross-site request forgery protection. This is very much an off-kilter one. But in terms of session management, the existence of a CSRF token in a web application should be a requirement. It brings zero value to the application, with the exception of the fact that attackers can't steal the user's session variables, which is a benefit. But it's a negative benefit. You know what I mean? It's one of those things we have to add this in so people can't do this, which I guess is sort of what encoding is too. Anyway, cross-site request forgery protection should be a requirement in an application. So that's requirements. Let's talk about design for a little bit. How am I doing on time? Ooh, wow. Wasn't I the one who said this is a short talk? Okay. In the design phase, the entire goal is to reduce the attack surface. That is what we are trying to do. We have reviewed and applied the principles. We have added in requirements for security controls. Now we need to reduce the attack surface. This is very often something that's done after the application is built, which is threat modeling. If you do threat modeling as part of your design phase, it will dramatically increase the ease with which you can build security controls when you move into development. Practically no one does this. But strangely, you know who's really formulated a good system for this is Microsoft, of all places. Well, can't really blame them. I mean, they were pretty much the butt of every application security joke on the planet for, 10 years, right? So the fact that they took this seriously eventually makes a lot of sense. And we'll talk a little bit more about their processes later. But threat modeling was historically something that was done during the security testing phases of applications. When the application was already built, the threat model was developed by walking through the application manually and designing the model. Instead, when you're writing the high-level application design, you can build the threat model then and build the decomposition diagram. Very straightforward. Decompose the application into pieces, determine and rank the threats, and then determine the countermeasures and mitigation. And of course, threat modeling is an entire 1-hour talk on its own. And probably, since this is a security audience, most of you know about it anyway. If you don't, I'll have some tools at the end we can talk about. But this is the time to do this, is during the design phase. When your quality gate at the bottom of the design process, before you start development, a threat model should be in information security's hands by then. Let your software architect write the threat model. Give them an education, give them a tool. The tool's free, right? And have them write it. And development. What are we going to do with our poor developers? They get all the cruft, you know what I mean? I spoke to the .NET, the gang, Great Lakes Area .NET group, right? Yeah. So Microsoft, back in 2001, when .NET started up, they kind of funded this. They halfway funded this kind of grassroots movement of building user groups around .NET development. Because they really went in whole hog, well, and obviously it paid off, went in whole hog in the .NET thing at the time, which was considered a very risky move. And many of these groups sprung up. It's amazing how incredibly strong some of them still are. The group that was built in Columbus, where I'm from, it still draws 100 people a month. It's really amazing. And Gang is the same thing. I don't know how many people we had there last night. 70? Yeah, 70 people. It was a lot. And super interactive. I mean, I took probably a half hour worth of questions. Really involved and interested, but still, I gave my compressed testing training talk, which is Developer's Guide to Pen Testing, where I talk about information disclosure, injection vulnerabilities, and something else, session management vulnerabilities, what the vulnerabilities look like, and how I find them, and the O faces in the crowd were amazing. It's terrifying. They've got enough to do just getting the code to work, right? So what are we going to do? Pretty much the only tool we have in our toolbox with development staff is education. There are some other pieces, but education is definitely the starting point, right? So giving them the tools to learn, and then the tools to check things when they need to matter. And this is Team Mentor. It's an open source product, but the database for it is controlled. You can get access for your developers to tools like Team Mentor to look up potential vulnerabilities by feature type. So when you go and say, hey, I found cross-site scripting, that means zilch to a coder, nothing. And you say, well, look, I can inject arbitrary JavaScript. That means nothing. They need to be able to think, oh, I have a feature in which I have to use the referrer and I display it on the screen somewhere. That needs to be encoded before I reflect it. That's the way they need to think about it. So it's input validation to them. It's just the same thing as making sure a number is a number before I try to cast it to an int. Okay, using try parse. Right? That's the same thing to a developer. Telling them that they have a certain vulnerability does not help them. So instead, we need tools in play that translate between feature types and vulnerabilities. Team Mentor is a great example of that. Beyond that, they can go out into the community and ask questions. Stack Overflow is a fantastic place. Make sure two things. Make sure that you are not blocking access to these kinds of communities in your corporate policies. And two, try to educate your developers not to copy and paste their source code into their questions, please. Then, once they know, sorry, that's an eye test. What's on it isn't important. I'll tell you. What they know, once they have the knowledge and they have the tools for research, then we have to step into the code itself. Then we step into the realm of static analysis. So static analysis tools look at source code in a variety of languages and determine a potential vulnerability. This is HP Fortify. Recently I analyzed did full-on 2-week-long tests of 3 of the major players in static analysis and learned a ton. This is HP Fortify. It is largely considered to be the market leader according to Gartner. It is a monolithic application. Massive. It has individual endpoint controls that install on the developers' workstations, so that Visual Studio will actually give them a red squiggly, or Eclipse, or NetBeans, whatever it is you use, will actually give you a red squiggly if you type something in that has a source and a sink for cross-site scripting, and then it will teach you what you did wrong. And it will not let you check in your code if you leave it there. Then there is a central command center where all of the vulnerabilities that are discovered in the source code are brought to, so that you can analyze them later, make determinations about what the patterns are and how you're getting rid of things. Also, you can modify the rules for your organization. For instance, if you have a common data model, it's very likely that you aren't doing any input validation at that data model layer because it's understood that it's always going to happen at the service tier, and the data tier has to be fast for whatever reason. You may know that, but Fortify doesn't. So you can go into Fortify and make changes to the rules to say, hey, by the way, in this, don't worry about SQL injection here, because this never is used outside of this particular platform. Now, because somebody's going to say it later, I don't personally agree with that. I think Security Onion, right? Every tier should have certain checks, but if we can make certain assumptions about our ORM, we always use the ORM, then maybe that's going to be a rule in your organization. Fortify is when I did my verification of these three, Fortify was the one that we ended up selecting for that particular project. But one thing I learned is that what tool you use is very heavily dependent on your particular corporate organization. For instance, the place I was testing all of these for had offices in 3 cities on 3 continents in 3 different time zones. They needed that central control. Also, it was a desire of the client to have the developers get involved, which isn't always the case. Third, they had someone to manage it full time, which was very important. This is Checkmarx. Checkmarx is another static analyzer, and it was the one I liked the best. It is pretty much entirely developer driven. In fact, if you're an independent consultant, Checkmarx is the static analysis tool for you. It's very easy to use, it's much lighter weight, and it still allows you to modify the rules. In fact, you don't have to write strange cryptic commands to modify the rule set. You can do it in C#, which is just freaking awesome as far as I'm concerned. It has nice graphic displays of where the paths through the application fall, where it's found injection vulnerabilities or session alterations or anything of that nature. It's very nice, and it's also about 5% of the cost of Fortify. However, it doesn't have a central command unit, so it didn't work for what I needed it for. But it is a fantastic tool. This is IBM AppScan. IBM AppScan also did a very nice job finding vulnerabilities. However, it was significantly more difficult to erase false positives permanently from the system. And it also was a pain in the behind to install, which I know only matters once, but still frustrated me. You'll notice that of the 3, all 3 of them were large, corporate, expensive software packages. Part of the problem is that there are no good open source alternatives. The reason is static analysis is very, very difficult. It's very hard to do poorly. It's extremely hard to do well. However, if you take the time to get a static analysis program in place, your developers will be better. You teach them, you give them the tools for research, and you give them static analysis. Hey, by the way, one other tool that I don't have slides for that I'm recently learning about is Veracode. Veracode scans at the kind of the machine language level, the byte level. You send it your jar files, you send it your DLLs, and it scans from there. And I've been working with it on a client I have right now, and it's remarkably good. And it's proctored. The tests are the scans are proctored, so a human goes through and gets rid of false positives and cruft. So you really get an actionable report back. And it's service driven. Of course, the problem is you have to give them your IP, which a lot of places, well, like the government, you can't do that. Maybe they have a deal with the government or something. I don't know, but I mean, I know lots of places that simply it's against corporate policy to give up your binaries like that. But if it isn't, you might want to consider it. So testing. So once the application is in test, you have this dichotomy that people always discuss, which is scanning using an automated scanner or an active scanner, right? Or testing by a human. So there's a whole lot of scanners that will look for common targets. And actually, scanners are very good at finding some things like injection flaws. However, yeah, I'm sorry, I've got to have that. Got to have that in every deck. I just, you got it now. It's a thing. The problem is that the scanners are missing one very important piece of the testing puzzle. That is also why we haven't automated QA yet. And we still have QA people. And that is insight. Humans testing can find other information about the application that a scanner simply does not have access to and never will. They can go through and make a map of where other pieces of software that were combined to create your software came from, what the people were, who the people were who were involved in that project, and what else they have done online in order to craft attacks more carefully. The scanner cannot do that. All it can do is go through a word list, which I will go through a word list as well. When I go to test, I use automated tools. This is Burp Suite, and this is Zed Attack Proxy. Burp Suite is a commercial tool. Zed Attack Proxy is an open source product that's an OWASP project that's managed by Mozilla, paid for by Mozilla, the same company that builds Firefox. And these tools make manual testing of an application a little bit more automated, but it's still effectively a human doing the work up front. And that insight factor is what makes these tools usable. I can craft attacks knowing things about the application, using my previous experience, researching a developer, find the developer's name in the comments, look up their LinkedIn profile, look up their Stack Overflow profile, and find where they pasted the source code of your application into their question. I think I mentioned that before, didn't I? So going through this process, this manual testing process, is key in the QA phase of the application. We've already done all these other controls. Now it's time to make sure those controls actually work. And having a human capable of testing the application in QA at least once will make a significant difference in reducing that 23x cost we saw trying to fix them in production. What I've been having people do is train their QA staff on Zap. I've done it at 2 companies now, and it has been remarkably successful. I think it's the solution to the problem. The fact is vulnerability analysis isn't really that difficult. There's just a lot to do. There's a lot of steps. My personal analysis spreadsheet is 390 entries that I go through for every app. Now that might be a lot for QA to go through, especially for Scrum. Oh my gosh. But doing some process like that with your QA is going to be key, using tools like Attack Process. How about deployment? So deployment tools are like a strainer, right? They're designed to filter out the cruft, the comments, all the temp files, the backups, the data. So, and they also should sort out data. I don't mean bad data like test data. I mean like the authorizations you use for testing and whatnot. So, user accounts, test data, there needs to be procedures in place to get rid of all of that on deployment. When you move your database, all that information needs to... I told you I didn't need that. But I do, don't I? So are you starting to get the idea with pictures? Your deployment process should be a filter. It should clean out everything that isn't actually required to run the software. That's what it should do. It means a lot. It is the key to a tremendous amount of this information disclosure that we're discovering, finding .bak files, finding backups of the of configs and like that in the software. And a nod to the hardware people too. Now network security matters. Okay, this is when we get NetSec involved, because at this point, if we give the developers the keys to deploy the application, all the scripts in the world aren't going to matter if they right-click on the web folder, go to security, and click the everyone group, because they can't get some little feature to run because of permissions. And trust me, they will. I've done it like 900 times. So remember separation of duties way back in scope? Yeah. Now we give the NetSec people and say, okay, make this app work, and give them the tools to do that. So maintenance. So I mentioned pen testing in an earlier statement. So you did it in QA, right? Well, realistically, you're going to need to do that every year or so. And then this is a good place for scanners too, because there are a lot of things that scanners do find. Like I said, injection vulnerabilities and information disclosure are often discovered by scanners. That's also the stuff that tends to get added when a developer has to make a patch to software. They leave a comment in, hey, I made this change to software. That comment will get discovered by a scanner. So quarterly, anybody here in the finance industry have to do your quarterly PCI scans? That's actually not horrible for this kind of testing in maintenance. But a human should look at the app once a year or so. And, that's right. I was supposed to bring up logging earlier. I actually needed to add that to the piece. So hopefully you thought about logging before now. But logging in your application, we can say that was part of exception management. We'll just pretend. So logging is now your lifeline to this application. Not just the act of the application doing the logging, but also you being able to react to what the application is logging. So whether you've got a corporate solution for log management or you need to build something to watch the logs, to watch for attack activities, to watch for problems, either way, something needs to be done to maintain those logs. Those logs are your window into the life of that application. So eventually we have to get rid of it, right? So when you sunset the application, the destruction of the data used to run it is paramount. Now, we're going to keep the information, okay? We can keep the information and migrate it to the new system, but that data must be destroyed. You cannot leave the old tables laying around in the database. They will probably get found by somebody you don't want to find them. Also, it's much more likely that old authentication information or authorization information will be stored in the new version of the system if you just move the data over. So take the time to build something to move the information and then destroy the old data. And then there's one other really important thing you need to do that we can bring from the Scrum world, and that's a retrospective. We need to go back after the death of the application and say, okay, what did we do right? What did we do wrong? How did this go? It might be hard. The app might be 15 years old. Do it anyway. Even if it's just a 20-minute meeting with a couple of the people who were in charge of keeping the app running. Sit down and say, okay, what was right and wrong about this application? Because when you start the process over again, that's where you'll be able to use this information to improve it the next time you go around. So let me spend 5 minutes talking about resources. So I talked about Microsoft. Microsoft has something called the SDL, the Security Development Lifecycle. And it is designed to follow the software development lifecycle, right? And it's a little specific. So it's a fantastic thing. Microsoft came up with it when they shut down the whole company before Windows 2000 to fix security. This is what they did, and it works. It genuinely works. I mean, obviously, you look at security and the way security is today in Windows software and the way it was 15 years ago, there's really no comparison. It is a really good process. However, it's a little focused on Microsoft products. It's a little driven towards deployment of the kinds of tools you find in the SharePoint, or tools like SharePoint that you find in the Microsoft space. So OWASP has a couple of nods towards security, software security lifecycle. OWASP is the Open Web Application Security Project, and it's a global organization designed to teach developers about application security. They have something called the Secure Software Development Lifecycle Cheat Sheet that's basically just a 5-pager, and it's not really going to get you very far. But there is something that will. The Application Security Verification Standard is a way for tool vendors to communicate with clients, customers, to describe their security. And it's a a multi-tier system that allows you to describe how well you meet certain areas of application security. Oddly enough, it also gives you a way to structure a real test plan for your applications. It's not so much a security lifecycle in itself, but it will give you all of the individual detail points that you need in order to develop those gates at the bottoms of each of the applications. There is an OWASP code review process as well, but that's really just for code review and it doesn't apply as well as it should. So the goals of the ASVS are about certification of applications, and if you squint a little bit, you can see that really all of the pieces are there to wrap into the SDLC. You'll have to do it yourself, okay? You'll have to take the ASVS and map it to your security lifecycle, what parts apply to you. But all of the focus on authorization and constraint of privilege and all those pieces are in there. You just need to map what goes into what gate. So the goal is to bake it into your own software development lifecycle, modify this image so that it matches your company's security needs. And I think we've got some tools to do that now. So I'm Bill Sempf. You can find me on Twitter. Thank you all for coming and listening. I hope you enjoyed it. If you have any questions, I'll be around for the rest of the day. And thank you. Thank you for your time. Any questions? I'm actually right on time. But any questions for the good of the group? Yeah, go ahead.
How do you measure the effectiveness?
Great question. That's a little outside the scope of the talk. The question was how you measure the effectiveness. And it's a little outside the scope of the talk, but it is something I need to research. I don't have an answer right now. I'm sure there is a way. There are, if you look at the Microsoft SDL, they do have metrics that they match. And it's very good. And it's really just a matter of metrics, like the stuff that Rafe was talking about, the mean time to discovery, mean time to remediation, that kind of stuff is along the lines of, hey, as we're building software of certain levels of complexity, how deep are the pen test reports when they come back? You know, are they getting? How are we doing? And that's one thing where static analysis is going to help you a lot, because you can look at the code that's coming out and say, hey, look, we've got 620 findings. The last time we wrote a piece of software like this, there was 12,000. So that's the kind of metric you can look for. Anything else? All right, I'll get out of the way for the next person. Thank you all very much. Hope you have a good